Let's take a look at this one right here. Okay, so can somebody tell us what an inequality is? Just in your own words, doesn't have to be anything technical. No one?
Something with a greater than, less than, or 2 sign.
Okay, so maybe we could call it expressions. Maybe they have numbers, maybe they have variables, okay, with greater or less than in between them. It's basically saying one is bigger than the other. Okay? And when we solve an inequality, what does that mean? What do we get when we solve an inequality? Think about how we solve an equation and think about what we get there and think about what we get when we solve an inequality. Sven? Okay, so we get a range of answers. We get a bunch of answers that work usually, okay? And I'm going to call that an interval, which we'll talk about next. I think we've used this terminology before, this notation. So it says, write an inequality that represents the interval. Okay, so I think in P1 we were talking about inequalities and intervals and stuff like that. So this one says we've got the interval from 4 to 9. That means everything from 4 to 9, including 4 to 9. So if we want the x's that are in between 9 and 4, we want the x's that are greater than 4 and less than 9. Okay, and I need to add something else to this. What else do I need to add? Okay, I need to add equal to. So the way we'd write this is 4 less than or equal to x, less than or equal to 9. That would be the right way to write that one. Okay? If we're looking at this interval right here, here's -2, and then we take all of, so on this one, let me go ahead and shade this in. It's all of these guys right here. On this one, it's all of those guys there, all the way up to infinity, meaning we can get as large as we want. It's unbounded, as we say. Okay? So this one's unbounded. How would we write that? There are 2 ways that would work here. We want the answers over here, so we could say this. We could say -2 is less than x, and again, it wouldn't be included because it's not a square bracket. Or we could say this, x is greater than -2. Either one of those would be fine. We usually read the inequality from the variable, so sometimes this one's a little bit nicer. Okay. And let's take a look at this one. We want all of the answers in between -10 and -7. And it doesn't include this one, but it does include this one and everything in between. So here are the x's. So what we'd write is -10 is less than or equal to x, and that's less than or equal to 7. Okay. That's how we'd read that right there from left to right. -10 less than or equal to x is less than 7. Or we could read it this way. We could read it as x is greater than or equal to -10, and at the same time it's less than 7. Okay, so you could always read it from the variable. Oh, is it a -7? Thank you very much. Thanks for catching me there. Okay, and then let's take a look at the last one. This is from -infinity to infinity. Okay, this is the whole number line. This is everything there. So we could write x in the middle and then plus or minus infinity there. Okay, or we could just say this is all reals, right? That would work also. All right, let's take a look at this first one. Is this bounded or unbounded? It's bounded, okay? Bounded means it's kind of got endpoints. Whether we include them or not doesn't really matter. Bounded or unbounded here? Unbounded. And this one's bounded, and that one's definitely unbounded because we've got the whole XY axis. Okay? How do we solve inequalities? Can somebody describe how we solve inequalities? I know you've seen these before. Raymond knows. Who else knows how we solve inequalities? Hop knows. Okay. Raymond, go ahead.
Isn't it inequality close to equalities?
Yeah. Okay. So we solve them just like we solve equations. except, got to be really careful when we do one of two things. What are they? Okay, except when we multiply or divide by what? A negative. Okay, what do we do then? Okay, so we'll say this correctly. We switch the direction of the inequality. Right here. So we'll switch the direction of the inequality. Now, I'm not going to take the time to go through this example right here. Okay, but you could take this inequality right here, which is a true inequality, and you could do each one of these things and you could see if it's still a true inequality. So for instance, what if I add 4 to both sides? This would be -6 and this side would be 19. -6 is still less than 19, so it would stay the same direction. What if I took this and I multiplied both sides by -1? So what's -1 times -10? +10. This would be -15. If I put it this direction, would that be a true statement? Is 10 less than -15? It's not. So when you multiply or divide by a negative, you have to switch the direction of the inequality. Okay? And you could go through and you could check this right here. We can switch sides, but you can't switch sides without taking the whole inequality and flipping the entire thing over. So we couldn't do this. Whoops, -10. But I could take the whole thing, including the inequality, and do what we called, I think we talked about this last week, just do a big pancake flip. So we could do 15 and -10 and flip that over also. And that would still be true, okay? So the way you solve an inequality is exactly like you solve an equation, except for when you multiply or divide by a negative. So on a problem like this, treat it just like you would an equation. So we're going to get rid of the 7 by subtracting 7. So we get -3x greater than or equal to -12. Because the step that we took was just subtracting. That does not change the direction of the inequality. Now, Tara, what's the step we're going to take next? We're going to divide by -3, okay? The step we're taking to solve the inequality is dividing by a negative, so we're going to switch the direction. So this is going to be a less than or equal to, and that's a +4, and that right there is the answer, okay? Now, this says graph the solutions. So here would be the solutions. The solutions would start at 4. I'm going to circle 4. Should I fill it in? I should fill it in, okay, because it connects the equal 4. Do I shade the left side or the right side? Left side, okay? So we're shading this direction right here, okay? And we could write that in interval notation. And then it says choose a test point. Now this isn't a big deal right now. I mean, we know we got this right. This means pick any point you want in this interval. So let's pick a point like, probably the easiest one to pick that would be less than 4 would be maybe 0. Let's plug in a 0. If I plug in a 0, I get 0 here. I get 7 greater than or equal to -5. Is that a true statement? It is, okay? So we probably got that interval right just using that test point, okay? Any questions? Okay, Hope, what do we do on this one right here to solve that? Multiply both sides by 5. Now, if we multiply both sides by 5, does that change the direction of the inequality? Nope. So you get 2x plus 7. Over here we get, now some people look at this and say, hey, wait a minute. We multiplied by a negative when we got -45. Do I need to switch the direction? How would you explain to somebody that made that mistake why you don't have to switch the direction? Raymond?
You aren't dividing or multiplying both sides by negative.
Both sides. You didn't multiply both sides by a negative. And remember, it's the step that we're doing. So what did we do? We multiplied both sides by a +5. There was a negative there to begin with. That wasn't our fault or anything, okay? And then you'd finish this, okay? Again, in the interest of time to make sure that we get done with this, you can finish that, right? It's just like the last one. Okay. This one's a little bit more complicated. Is anybody like that guy right there? Makes the problem more difficult to deal with. We dealt with some rational equations last week, and we said if you don't want to deal with fractions in an equation, you don't have to. Okay? Can I get rid of that 2 if I want to? Yeah, how would I do it? Times both sides by 2. Now, if I multiply both sides by 2, that's a legal algebraic move. Do I need to switch the direction? No, I don't. Okay? I know I'm multiplying by a positive, so I know that when I multiply here, I'm left with 5 and x minus 2. What happens when I multiply here? Okay, I get a positive 8x. That's still going to be a greater than. When I multiply over here, that's going to be a 4 and 7 plus 2x. And then I can finish it from there. So this is going to be a 5x minus 10 plus 8x greater than 28 plus 8x. Something nice happens here. There's an 8x on both sides. And then I'm going to move the 10 over to the other side by adding 10. So this is going to be 5x over here. And this is going to be a 38. And then I divide by 5. Have we done anything wrong? Nope. So we get x greater than 38 fifths. We'd leave it as an improper fraction. It's already reduced. Now, if we were going to graph this, we'd need to think, let's see, 5 goes in there, 7 and a little bit more. Okay, so if 0's here, this would be 38 fifths right here. Circle it. Do I fill it in? Don't fill it in. Shade right or left? Yep, read from the variable. X is greater than that number, so we're shading on this side right here. And then pick a test point. This is a little bit more than 7. It's like 7.6, isn't it? So pick any number you want bigger than that. Say plug in a 10. If you plug a 10 into the original equation, it better work. If it doesn't, you've done something wrong. Okay? Any questions on those inequalities there? Because now it's going to get a little more interesting. Okay, so you know how to solve those basic inequalities? Okay, so now we're going to put the inequalities together into something we call a compound inequality. A compound inequality is simply a couple of inequalities that are connected by a word, and those words are either an and or an or. When we say the word and, it means both of the inequalities need to be true. Okay? And we use this symbol right here. Does anybody know what we call that? Anybody seen that before? Ringing a bell at all? Okay, a couple of you, I see some shaking heads. Okay, it's called an intersection. Okay, in other words, it's an overlap. That's what we're talking about. Okay, so if we use the word and, it means both, and it's an intersection or where the two inequalities overlap. Okay, and if we use the word or, it means one or the other or both. Okay, so the word or is what we call an inclusive or. It means and or, it means one or the other or both, okay? So we use that symbol right there. I'm hoping somebody has seen that. What is it? It is a union, okay? So it's a union, okay? And when we union things, we put them together, okay? So it's not the overlap or just the overlap, it's anything that's shaded, okay? So we put all the shaded portions together. So I'm going to do this one in kind of a color-coded fashion. And I'm hoping you've seen stuff like this before because that would make it a lot easier. Okay, so here's what it says. It says solve, graph, and write the answer in interval notation. So this is a compound inequality. It's inequality connected by the word and. And means that whatever the answer here is, both of these inequalities have to be true. So we're looking for, when we shade these, we're looking for the overlap, and only the overlap, because they both have to be true. So if I solve this one, all I need to do here is just divide by 3, right? So I get this inequality. I get -4 less than or equal to x. And when I solve this one over here, I'm just going to subtract 2. So I get x is less than 2. And the word that connects these is and. So we're looking for where they're both true. So I'm going to graph this over here. So here's -4. I'm going to circle that. Do I fill it in? We do fill it in. Which way should I shade? To the left or the right? Careful, read it from the variable. X's are greater than that. So we're going to shade this side right here, okay? So that's what I'm after. Those are the answers to the red inequality. Okay, now I'm going to do the blue inequality. The blue inequality, okay, the number there is a 2. That's the most important number on that one. Okay, I'm going to circle it. Do I fill it in? I don't fill it in, and then which direction do I shade, to the left or the right? I'm going to shade to the left, okay? So we're going to shade this way. Okay, now, I've got colors here. If you don't have colors, that's fine. What I like to do is I'll shade one kind of, see how I shaded the red one going upward? And, okay, doing the blue one, I kind of went downward. Okay. If I want both of these to be true, if I want this one to be true, and at the same time I want this one to be true, what part of the number line do I use? Okay, it's the overlap. It's where they're both true. Okay, it's where it has both types of shading. So let's transfer this over here. So this is kind of like the work. Let's do our final answer over here. I'm going to have a -4 and I'm going to have a 2. I'm going to circle both of them. Which one gets filled in? The -4 gets filled in. Okay? And I'm going to shade everything in between here. Any questions? So the easiest way to write this one, and is the only compound inequality that can be written without the word. Here's what we'd write. That's how we could write the answer as an inequality. That's how we could write it as a graph. And we could also write it in interval notation. We'd say the answers start at -4 and they stop at 2. Square brackets around the -4, round brackets around the 2. Okay? 3 different ways of expressing the answers to that. Inequality, a graph, and interval notation. They're all important. Okay, any questions there? Sure? Okay, raise your hand if you've seen that before. Okay, just kind of need a little jog of the memory. Okay, let's do the same thing on this one then. We'll solve this guy right here. Let's see, if I'm going to solve -5x greater than 20, divide by -5. That's going to switch the direction of the inequality, so that's going to be x less than or equal to -4. Okay, the word that connects those is or, so one or the other or both. And then we'll solve this one right here. I'm going to move the 3 over by subtracting 3. So this is going to be a 5 less than x. So here's -4. X is less than that. Again, read from the variable. Here's +5. Circle that. Read from the variable, shading greater than or less than, to the right or to the left. X is greater than. Shade over here. Okay, what's the word that connects these? Or. Or means one or the other or both. One type of shading, the other type of shading, or both. In other words, anything that's shaded, we're going to put that together in the union and we're going to say that's part of the answer. So the nice thing about these is, I mean, you really only, that is the answer right there. Okay, if I kind of make this uniform and do, let's make a nice looking graph here so we could tell. The only way to write this is as an inequality is using the word or. So we'd write x is less than or equal to -4 or x is greater than 5. Again, notice how I did a little pancake flip there? So we could read it from the variable. It just looks like that. And then if we wrote this in interval notation, okay, take a look here. I'm going to start way down on the left. What's the number or the idea that's way down here on the end on the left end? -infinity. So we're going to say it starts at -infinity. Where do they stop? Stop at -4. Okay, always round around -infinity and then a square bracket around this because it's included. Do they start up again? Do the answers start up again? Yep, they stop for just a second and they start up again where? Okay, they start up at 5. Don't put 5.1. Don't put 6. Okay, don't put 5.001. They start right at 5, we just don't include that, and then they go all the way to infinity. Okay? And I'm so hoping somebody can correct me here because we're not quite done. Hope. You need a union, because what we're saying is we're going to put these two together. Those two together are the answer. That's why we call it a union. Any questions? So there's the inequality, has to be connected by the word if it's an or. There's the graph of the inequality, and there's the answer in interval notation. Okay? Again, all three of those are important. Any questions on that first page? Okay. Luckily for you, if you flip the page over and if you've looked at the homework assignment, okay, how many of you are mostly done with P6? Okay. Anybody all the way done? Excellent. Okay. All right. Lucky for you, they don't use the or inequalities very much. Okay. They stick with the ands, and those are a little bit easier because, like I said up above, you can actually write that as one single inequality. Okay, like we did right here. Okay, we'll call it a double-sided inequality, or you could call it a three-sided, I suppose, if you wanted to. We're going to solve this one right here. This is a compound inequality. They're connected by the word and this is the way it works. We want 3x minus 5 to be greater than or equal to negative 8, and at the same time we want it to be less than 13. So the awesome part about this is I can just solve it like I would an equation. We want to get the x by itself. So I'm going to add 5 to every one of these. Does that change the direction of the inequalities? Nope. So this is a negative 3 less than or equal to 3x less than or equal to, and this is an 18. And then all I do is divide by 3. So this is what I get. Negative 1 less than or equal to x less than or equal to 6. Now that is the answer as an inequality. You could write it in interval notation. The answers start at negative 1 and they end at 6. What type of bracket around the negative 1? Round or square? Square. And what about the 6? That's going to be round. Now, it says choose a test point. Again, we'll just do this on one of these. It's not a big deal. Okay? I'm going to choose a point in between there. What is the easiest number that we could plug in between negative 1 and positive 6? 0. Let's plug in a 0. If you plug in a 0, I get negative 8 less than or equal to negative 5 less than 13. Is that inequality true? Pretty good numeric evidence that we got the answer right? Yep, not bad at all. Okay, any questions? Okay, somebody tell me what we ought to do with this one right here. What should we do with B? Somebody other than Raymond. Sorry. Tony? Times everything by 3. If I multiply everything by 3, and what's a big deal here is it's a positive 3. Why is that a big deal on an inequality? Why is it a big deal that we're multiplying by a positive 3, Tammy? You don't have to switch the direction of the inequalities. So this is going to be negative 3. Help me out here. 6. Don't skip that over. Okay, every term needs to be multiplied by the same thing. It's not fair to multiply this one by 3 and not multiply that one by 3. That's going to be a minus x. That's going to be less than or equal to positive 3. Continue solving. I'm going to subtract 6 from everything. That doesn't change the direction. So this is negative 9 less than or equal to negative x less than or equal to positive 3. And then Nathan, what do I do to finish this? Did I make a mistake? What did I do? Oh, that should be negative 3. Thank you. Thank you. Divide everything by a negative. Or, in other words, run through and change the sign of everything. Or, on this one, could I multiply everything by a negative 1? Any one of those things would be okay. Okay? Now, if I do that, that's going to change this to a 9. That's going to change this to a 3 and going to change that to an x. What else do I need to do? Change the direction of the inequality. So that's going to be a less than, that's going to go from a less than to a greater than, that's going to go from a less than or equal to a greater than or equal to. Okay, does this bother anyone? Have we done anything wrong? We haven't done anything wrong. Okay, is this the best way to write that? I mean, maybe by the fact that I'm asking that question and waiting a second. Probably not the best way to write that, okay? Could you tell me why that's not the best way to write it? Brandon. Excellent. Say that again, that last part. So what? You want the smallest number in front, or in other words, you want to go from smallest to biggest? The smallest number, so this is going to be 3, and this is going to be 9. X is in between. There's our less than or equal to, and there's our less than. That's the answer. And again, you could choose a test point and graph it, write it in interval notation and all that sort of stuff. Okay? Any questions there? Sure? Okay. Now we're going to do something kind of interesting. So this is what we're going to do. I'm going to do these two problems and maybe get to example number 8. I'd like to finish this tomorrow at the beginning of class. Okay, because these are important ideas. These are going to come up again, and you're going to see these on the test. Okay, so tomorrow we'll finish this up, and then we'll take time and we can do P7. Okay, all right. So let's take a look at this right here. These are what are called absolute value inequalities. Okay, and these can start to get a little bit confusing, especially when we do stuff like these examples right here. Okay, here's what this means. Okay, in order to get this right. Okay, absolute value refers to distance from 0. So whatever this is, whatever x is, its distance from 0 has to be less than 5. So if 0 is right here, you can go forward to 5 or down to -5, but you can't go any further in either direction. So that means it would only be that little interval right there. Good there? The easiest way to do this is to kind of think of it that way, okay? Remove the absolute value. That's one inequality. That's the one that's less than 5. And remove the inequality and throw a negative on there. What would happen on an inequality if I just introduced a negative? What do we normally have to do with an inequality if we put a negative on something? Change the direction, right? So this is going to be a greater than -5. And the word that connects those is an and. So it's got to be less than 5 and at the same time greater than -5. So I could write that inequality this way. Notice I could do a pancake flip on this one. -5's down here. +5's up there. And we're talking about the ones in between them. Okay? Now that's for a less than. Less thans are usually pretty easy. Okay? Less than, you can translate that into an and. Again, if you've got the x on the left-hand side, and then it's a less than, like this one is right here, okay, that's going to translate into an and. If it's a greater than, stop and think about what this means. That means however far this is from 0, it's got to be more than 6 units away from 0. So there are two ways to make that happen. If 0 is right here, I could be over on this side of +6, or I could be on this side of -6. So the way I could solve that is I could remove the absolute value, and I'm talking about 3x being greater than 6 on this side of +6, or I'm talking about 3x, what is it compared to -6? Less than. Okay, and notice how when we introduce the negative, we switch the direction of the inequality. So that means the answers are over here, or they're over here. Okay? So then we have to finish solving that. So I divide both sides by 3 here. I'm talking about x's that are less than or equal to -2. Or if I solve this one, divide by 3. X is greater than or equal to +2. So if you think about what that looks like, here's -2, here's +2, that's where the answers are. And again, you could pick a test point to check and make sure. We could write that as an inequality. It has to be written this way. Remember, if it comes in two pieces, you have to use the word or to connect them. And if we wrote it in interval notation, it would start at negative infinity and stop at negative 2. Square bracket here. The answers stop for just a second, and then they start up again at 2, and they go all the way to infinity, and then the only other thing we need there is just that union symbol to say we're going to put these two intervals together, and that's the whole answer. Okay? Any questions? Okay, are those pretty easy? Not too bad? Cameron, how we doing? Good. Okay, so I've got a little step-by-step procedure. The first couple are pretty easy, okay? You usually isolate the variable part of the expression. In this case, we're going to isolate the absolute value. So you're going to get the absolute value by itself. Okay, then you're going to break it into two different cases. Just like solving an equation, one of them is what you get when you just remove the absolute value. That's it. One of them is what you get, and I would prefer that you write them in this order. Write the one with the negative over on the left-hand side and write the one with the positive on the right-hand side. When we put a negative in there, what else do we have to put in there? Or what else do we have to do to kind of compensate for that? Switch the direction. So this is going to change to a greater than. And if it's a less than, it's an and. Okay, we're going to do the exact same procedure on this one. I'm going to take off the absolute value, and we're going to solve that one. I'm going to take off the absolute value, put a negative on this, and if I put a negative on that, what do I have to do with that inequality again? Switch the direction, okay? And on this one, it's a less than, so it has an and. What goes in between here? This one's an or, okay? All right. We're going to stop right there. I'm going to pick up. I'd like you to be able to solve these two. Have these solved tomorrow, and we'll check and make sure you got it right. We'll then finish this here, and then we'll do P7. Okay? Any questions? So, no, because I'm not quite done. Somebody asked me some questions that deal with these, and these are the most difficult ones on here, in my opinion, along with the domain questions right here. So we'll deal with those. So P6 will be due Wednesday, okay? And you should look at P7, be ready with your explanation of what that common error is, explain that, and then have an example of the correct way to do it. And then hopefully we can finish P7 tomorrow also, okay? All right. Okay, have a great day. You're out of here early, correct me if I'm wrong. That hasn't happened yet, right?